Welcome to mechanical tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like part modeling, surface modeling, sheet metal enclosure design, plastic components design, product design, reverse engineering, simulation, and many more tips and tricks in SolidWorks. Hi, today I am going to explain about brass fitting transfer adapter. Left side you can see the component, right side the cross section of the component. So this is the component I am going to create. So let's start now. I've taken a new SolidWorks part file. Select the front plane, go to sketch, draw one center line, draw one line from the origin vertically, and this value is 10 mm. So I am going to create a revolve feature. So let us coincide with this, and I am closing the loop. See, when we close the loop, it shows the shaded form. So if you select this option, this is better. If you close it, the loop is open, it doesn't show this shaded form. So this is the advantage of shaded sketch contour. So we can use this option, and this is 8.5, this is 8, and once again this is 8.5. See, this value is 13.5. So these are the diameters. So this is 16. Now I am going to select the revolve feature and say OK. Now select the face. So we have to select this face and go to sketch, draw one polygon with 6 sides, that is hexagon. Select this and select the vertical constraint. So this is vertically defined. Now select these two lines, and this value is 17. So it is fully constrained now. Now I am going to select the extrude boss, and this is 5.5, and flip this arrow and say OK. Now select the front plane. See, make sure that the sharp edges are parallel to this front plane. Select this front plane and go to sketch. So for better visibility, keep it in wireframe. Now draw one triangle. So this value is 1 mm. Now select these two lines and make it equal. So this is fully constrained now. So we have to mirror this. So I am going to use one small line vertically and select these three lines, select mirror entities and mirror about this center line. Now I am going to draw this center line. This is for revolve feature. So go to revolve cut. So here we have to select the revolving axis of this horizontal line. So this is very much important, and say OK. See here. Now select this face, go to sketch, draw one circle. So this is 4. And go to feature, select extrude, select through all and say OK. See here. Now select the top plane, go to sketch. So we have to draw one revolve feature. So we have to keep it in wireframe. Draw one center line. Select this edge, convert entity. Move this point to this center line and move this point little bit down and draw one horizontal line, inclined line and vertical line, then close this loop horizontally. See, this loop is closed. You can see the shaded form. Now we have to assign dimensions. Select these two lines and this angle is to 125 and this is 9.3 and this is 4. This is 10 and go to revolve cut and say OK. See here. Now I am going to apply chamfer. Select the chamfer command. Select these two edges. So we have to reduce the value, that is 1 mm, and this edge and this edge. These 4 edges we have to select. See here. Now I am going to apply these thread features. Select thread command, and select this edge. See, I'll say OK, and after that I'm going to explain. See here, it is starting from here. We can see this thread. See here, it is starting from here, so which is not feasible. So what we have to do is, we have to apply offset and flip the direction, and this is 2 mm, and the blind value of 10 and see here specification type, we have to select the metric die. See here we have an option, so we have to select the metric die, and since the diameter is 16, we have to select 16 into 1.5, and we have to keep thread method as a cut thread, and thread option right handed thread, and say OK. See here, you can see this thread now, so there is a smooth transition in the cutout, so that is very much important. See here, now I am going to create a thread feature for inside dia. See, we have to see this diameter, we have to remember also, this is, see, we can see downward diameter is 10 mm. When we click this edge, we can see the diameter at this point, exactly bottom, so that is 10 mm. We can remember, or we can simply select this edge and identify the diameter. Now I am going to apply the thread command. Similarly, we have to select offset and flip the direction, and the blind value we can keep 7 mm, and here we have to select the metric tab, and since the diameter is 10, we have to select M10 into 1, that is pitch value, and here thread method we have to select cut thread and a right handed thread, and say OK. See here, this is the feature created. Now we have to apply thread at this location, so select this edge, this is also 10 mm, so we have to go to thread feature, so we have already selected this edge, and similarly we have to select offset and flip the direction. See, it is moving this direction, we have to flip this, so select opposite direction. See here, now the blind value I am going to take 8 mm. See here, next so metric tab M10. See here we have to select metric die and M10, and thread method cut thread, and say OK. See here we can see there is no smooth transition of the cut. Select this face, go to sketch and select convert entity, go to features and select extrude cut. See here, you can see this, so there is no interference at any place, so we can take any value, so I am taking through all, and say OK. See here, there is a smooth transition. So this is how we create the thread feature. So this final component is ready now. I'm going to show you the cross section of this. See, this is how it looks internally. So this is brief about brass fitting transfer adapter in SolidWorks. Thanks for watching. For more videos on SolidWorks, please subscribe to my YouTube channel, Mechanical Tutorial.